Hello, this is a look at Spearman's rank correlation coefficient, and this is Mr. Spearman. Mr. Spearman was, as you can see, relatively recent, and a lot of statistics is relatively recent, whereas some of the old pure maths, can go back hundreds and hundreds and thousands of years. But this is relatively new, and what Charles Spearman here did was he found an alternative. Now, we've already seen in exercise 5a, we saw two versions of the same kind of work on how to find R. And R, you might recall, I called it Pearson's product moment correlation coefficient. It's either double P at the front or PMCC, it's often abbreviated. And it finds correlation between two things. So if you've got things going looking like this, and you might have two variables, one's x, one's y, and you can see there is a line of best fit almost, and that line of best fit leads us to be able to find this R value, how much correlation there is. Now, there are sometimes, when there is a correlation, for instance, still going up, doesn't seem to be going up, but then you can see it's almost like a curve correlation. Now, this you can't find a correlation coefficient of any validity anyway, using this R value, but you can use Spearman's rank. So Spearman's rank has its advantages. It has disadvantages too. It's a pain in the neck really to find it, and we call it little RS like that. So there is this alternative form, and I want to do it today. Now, before I do that, though, I want you to do a little starter, and this little starter is just designed for you to show that you know to yourself that you can find Pearson's product moment correlation coefficient. So, look, there are basically three methods. First method is you chuck it in your calculator. This is on your calculator. Now, I've shown people how to use the Class Whiz or the Texas TI-84 Plus is the other one my students use. So on your calculator, type those in, and you want, remember that what I'm after you to get is a value for R equals. That's what I want. Now, sometimes you don't get given the actual numbers themselves. You get given these summary statistics. And these are the formulas up here that you're meant to use. We've got a formula for R. And then for each individual part, SXY that's usually what you get given. SXXXY. So but I will point out there is an alternative way of writing these things down. Now, SXY then, and SXX and so on can be written like this. Now, this one is SXX. Notice the way it's sometimes written, the sum of the X minus X bars all squared. This is by definition SYY. And this one is SXY. So if you get onto the C, you can literally just type these things in because you know what they are. You don't have to find them at all. So I have seen them come up. I think they came up in the textbook from memory on exercise 5a. But can you type those in? So probably the hardest one is B. And pause the video now and do those three questions. So look, I even typed that last one in. I wasn't quite sure that I was talking sense, but it did work. So I typed these in. I got the same answers I got last time. So hopefully you've got the same answers as me. And here they are then. So I've got 0.607 on the calculator. It's minus 0.550. Notice all to three sig figs. And the last one, which was quite a straightforward one, just using this top equation here, really, minus 0.714. Now look, Spearman's rank then. So we are going to get a set of numbers for two, for two variables, and we're going to see if there's any correlation between them. Weirdly, there's two ways to describe correlation in terms of hypotheses. You can either talk in terms of independence, or you can talk of association, and we'll need to do that in a bit as well when we come to do it. I've already explained that we call this RS, or Spearman's rank correlation coefficient, and this is the formula. Now notice, by the way, this is what looks horrible, but it actually is quite easy. This should here really have like a little times there, 6 times by this sigma d squared. D, by the way, is the difference in the ranks of individual, I don't know if I'm looking at my height and my weight. I'd rank my height, I'd rank my weight, and I'd work out the difference in me, and then it might be that I'd do the same for 10 other people. And n is the number of pairs of data that I have. So notice we do have to do this for hypothesis tests, and other than that, it's broadly the same thing as what we've seen before. We get, again, a new set of critical values. So you get these critical value tables in the formula book, critical values. I hope I spelled that right. And we work out the value by looking at whether it's one tail or two tail and what significance level it is and what the end value is, how many numbers we've got. So here's a question for us. We're going to look at whether or not there is correlation between temperature and whether or not ice cream sales go up or down. Now, the assumption is, I suppose, there is a positive association, i.e. the more temperature is high, the more ice creams I sell. Notice I'm talking about this in terms of association, so get used to this. It can be talked about in terms of independence. I think from memory, you generally use association when you're doing Spearman's rank. So positive association and no association. And let's find RS. So what are we going to do? So here's the actual numbers, and I don't know what they are, what they represent, whether it's thousands of pounds or just, hundreds of pounds, or just he sold £585, who knows. So in 2015, all right, so I'm going to rank them anyway. So I'm just going to put a little number next to each one. My lowest one is there, then that one. So notice smallest first, 1, 2, 3, 4, 5. Now you can do it the other way around as long as you're consistent with both sets of data. And temperature, what's the lowest temperature? That's the lowest temperature. And then that one. That one, that one, and that one. Now what I do is I find the differences, and the differences, by that I mean not between the numbers themselves, I mean between the ranks. 5 and 5 is 0. 4 and 3's difference is 1. Similarly, 4 take away 3. 3 and 1 therefore is 2. Now interestingly, 1 and 4, you might be tempted to write -3. I personally still write 3 because I'm going to square them in a bit, so it makes no difference. 2 and 2 is 0. Now I'll find the d squared, so I'll do that. 0, 1, 4, 9, and 0. And then I find sigma d squared. I add them up. And I get 14. Now notice my formula again. It was 1 minus 6 times sigma d squared over n times by n squared minus 1. It's a relatively easy formula once you remember it. It's 1 minus 6 times 14 then, over n, what was n? There was 5 numbers, times by 5 squared minus 1. Now, 6 times 14 is 84, I think. 6 times 14, turn my calculator on, is 84. So this is 1 minus 84 over, that's 24, times by 5, that's 120. So 1 minus 84 divided by 120. I get exactly 0.3. Okay, so I now know what the coefficient of correlation is, 0.3, according to Spearman's rank. Now, if I just go back a step, I can then go and look at my table. What was it? My n was 5. It says it's a 5% significance level, and it's one tail. 5%, so that's there. So I come down here and look, that's my critical value. 0.9. All right, so look, I can now write the critical value equals 0.9. And my value was 0.3 is less than. You will start with the test statistic, and then you compare it to the critical value. 0.3 is less than 0.9. And when you're less, that basically means you haven't got enough correlation to be convinced there is any correlation. I need lots of correlation to be able to say they're correlated. But it turns out that I haven't got very much. So I do not reject H0. And I suppose the only thing I now want is the wordy bit. And of course that's just going to be like one of those insufficient evidence jobs. Let's see what I've done here. Do not reject H0. Insufficient evidence at the 5% significance level to say there is an association between ice cream sales and temperature. Notice again this use of the word association rather than just saying there's correlation. We say there's not enough evidence that there is an association. Now get used to that. You need to write that. Okay, second example. 2 judges rank 8 tomatoes for gardening competition. Now these quite often come up. Your test basically is, do the judges agree? And for that you need positive correlation. So I suppose we're going to say H0, no association. Now I'm going to be a bit lazy because presumably in a bit it'll come up with the proper wording. But it's no association between the judges' scores. And H1 will say, well, we might say there's a positive association. I'd be surprised if this is a two-tailed test, because you wouldn't really want your two judges completely disagreeing with each other. Positive code. Now, both of those need more detail, and you can write those in your answers. Now, what have we got here? Have they got these are actually what the judge thought. So this judge number one said tomato C was first. It's the best tomato in the competition, or the worst. Doesn't really matter actually. I don't know whether or not these are the best or they're or the worst. But as long as they're in agreement in terms of the way they've numbered them, I can use it. These are ranks, so I don't need to rank them in this case because they're already ranked. So I'm just going to write here already ranked. Ding. So what's the difference between them? That's 1, that's 1, that's 3, that's 0, that's 1, that's 0, that's 1, and that's 3. And again, find d squared. That's 1, 1, 9, 0, 1, 0, 1, 9. So what does that give me? Sigma d squared equals 2, 3, 4, 22. And therefore RS is 1 minus 6 times that 22 divided by, how many numbers have I got? I've got 8 numbers, times by the 8 squared minus 1. And that's 1 minus 132. No idea what 8 times 63 is. 8 times 63 is 504. 504. So I do 1 minus 132 divided by 504. 0.738. Make sure you get the same thing. So what do I need? Oh, well, I need a critical value. So if I just go back, well, what is it? It's a 5% positive association. So I need to go back here. 5%, but still looking down the same thing there. Now, critical value is going to be determined by the fact I had 8 numbers from memory. So 0.6429. Let's go back to that question. So I've got a critical value of 0.6429. Now, I might as well just use the answers I'm going to get on the screen, I think. But basically, you'll notice, look, 738 is now more than this. So how am I going to write that? Well, actually, I haven't written it here. I should write it here. So I'm going to say 0.738 is greater than 0.6429. And because this is true, I reject H0. I've got more correlation than I need. So therefore, I have sufficient evidence at the 5% significance level to say that John is correct. Because John, remember, thought they had a good level of agreement between the judges' scores. And that's 2 examples. We've got one more example here. And you often get this, actually, where your data looks different. So I'm going to write this out slightly differently. I'm going to go A, B, C, D, E, F, G. And the first judge said he was the best. Then it was B. Then it was E. Then it was 4. Then G got 5th. D got 6th, 7th. Whereas the second judge said, oh, no. 1, 2, 3, 4, 5, 6, 7. And look, this is, I suppose, me saying to you, and I'm not going to do this now, perhaps this is one that you can do or we'll do in class. These are the ones then which I would suggest to you are potential ones where they just present the data slightly differently. We've had 3 different versions of this now. We had the data where they gave us the numbers. This was the ice cream sales question where we had to rank them. We had the data where they ranked them already and we didn't have to do anything with them. And now we've got this data here. Now I've written them properly. Now I can find D and D squared. Then I can find RS and then I can test it. But I'm going to save that little question for you to do. If you're doing this via YouTube, then perhaps you'll want to see the answers. If you're doing this in class with me next lesson, then you'll be able to wait for that. But here are my answers for you to look at. And one way or the other, we would then do exercise 5B. So I hope that was useful, and I'll speak to you again on the next video.